Right, so we're going to take integrating to the next stage, but before we do, I've got a lovely little starter for you folks that harks back to year one and the factor theorem, which is something which you will need to bear in mind at least once or twice over the next couple of weeks. Okay. Great, so here's your starter, so pause the video and give it a go. If you've got no idea what's going on, with the factor theorem, if you bracket, if x minus 2 is a factor, then that means a value of x equals to 2 will make the whole thing equal to 0. So if I put positive 2 into x cubed minus 3x squared plus kx take 10, I should get 0. So that's what I'm going to do. So if you haven't done that yet, pause it and do it now. So we've got 2 cubed, take 3 times 2 squared, plus 2k, take 10, being 0. So that's giving us 8, isn't it? 4 times 3 is 12, so take 12, plus 2k, take 10 equals 0. Now if I move all these numbers across to the other side, I've got negative 22 plus 8 is negative 14. So if I add that to the other side and then divide by 2, k must equal 7. Right, that should be very useful. Right, I'm just going to show you two examples before we get on with some practice after that. What we're looking at today is kind of the reverse chain rule. And if you like to remember a formula instead of working through it, then we've got this that works. You might want to make a note of that, but you also probably need to know why it works. So as this is going to involve a bit of log type stuff, we're going to ignore that one for now, and we're going to have a crack at this one first of all. So what we're going to think about is what would happen if I was differentiating down towards this. Well, I know that I would be probably looking at, let's go, if I go one power above so that it looks much more like it. If I had y equals 2x plus 5 to the 5, using the chain rule, what would we do? Pause the video and see what you can do. So we would say u equals 2x plus 5. We would be bearing in mind, of course, that du by dx times dy by du is going to give us dy by dx, wouldn't we? We would then say we'd say du, equals 2. Just 2, doesn't it? Yeah, du dx would equal 2. And then we could also say that y is equal to u to the power 5. dy du is easy. We just multiply by the power, then drop the power by 1. And then we replace the u with the 2x plus 5, which is what it stands for. So we've got that to the power 4. And then at the end, we need to multiply together the 2 with that. If I times that by 2, I'm going to get 2 times 5, 2x plus 5 to the 4, which is 10 2x plus 5 to the 4. There's a reason I've gone through all of that quite as deliberately as I did. So I'm going to bear that in mind now. So the basic idea is when I integrate that, I know that my bracket is going to stay the same. I'm going to move this up by 1. I'm going to remember that I'm going to add c as well. But on top of that, I know that because I multiply, I'm going to then have to divide by the new power. That's nothing new, and we're going to call that multiplying by 1/5. But I'm also going to need to multiply or divide by this number, which we can do as multiplying by its reciprocal by 1 over 2. And that's because we're reversing the chain rule. So if you like, you can just remember that you take the whole bracket, you pump it up 1, you divide by that number, but you've also got to divide by whatever the coefficient of x inside the bracket is in the first place. So that's going to give us 1/10 2x plus 3 to the power 5 plus c. Now, deep breath and come over here. This really, I'd rather it to be, in fact, if you look in the physical textbook, it's actually written like this, which is a more normal way of thinking about it. And we know that if we were differentiating the natural log of x, that would differentiate to 1 over x, and we've already done some integrating going from 1 over x up to there, haven't we? So the only real big difference here is that we've got that 3 there, and so the experience of what we've done here might give you a clue as to what will happen. So we're going to go to ln of the modulus of 3x plus 2, but we're going to have to multiply it by a third because we've got 3x there, and remember to add our c as well. So I'm going to give you some practice questions from the exercise in the book afterwards. This is also from the exercise in the book. This is the kind of thing I really want you to be able to do. So take your time, write it down. You might want to give it a little go. See if you can crack it yourself. There's no reason why you shouldn't be able to. So starting off, we are going to be just saying that. Do we need to do that? No, we can just go straight to equals, I think, and we'll have a big square bracket, and we can say we're going to have a half timesing for that, and this is going to go up to a 3, so that's going to make that a third. Then we'll have the same bracket in there, that pumps up to a 3. We should put plus c in there, but we'll just for now, but remember that's going to disappear because this is a definite integral, isn't it? Because we're going to be taking the 3 value away from the b value in a moment. So that's the first little bit. We know that that's a sixth, so then I can say, right, I'm going to have 1/6 2 times b, take 6 cubed, ignore the c because that's going to be taken away anyway, and then we'll have 1/6 2 times 3, take 6 to the power 3. Oh, and that's rather nice, isn't it? Because 6 takes 6 is 0, so all this is going to become nothing. So we're going to be taking nothing plus c away, which means we don't have that c, and we've basically got nothing to worry about there. So all we need to think about now is that 1/6 of 2b take 6 cubed is going to equal what we've been told at the beginning, 36. Right, so next divide by a sixth or multiply both sides by 6 gives us 2b minus 6 cubed is going to equal 36 times 6 is 216. Which is a cube number, which is nice because then we can say that 2b take 6 is going to equal the cube number of 216, which is 6. Add 6 to both sides and we can say that 2b equals 12 and that therefore b equals 6. And we've done it. So not that nasty really. Right, so the last thing I'd like you to do is, or busy yourselves for a little while, practicing a bunch of that now. Now a load of those are going to go into log things. The two I really want you to focus on is C and G, but this is to stretch yourselves a bit further. Oh, and this should say x and cubed, by the way. So I'm going to sign off for now, but as soon as this finishes, right at the end, I will flash up the answers for these questions so you can mark them yourself. Okay, remember there's another video coming for the Bank Holiday Monday lessons soon. Cheerio, folks.